Good afternoon, everyone.
My name is Dale Loberger. I'm with BCS. Used to be with Esri, former Esri. And what I'd like to talk to you about this afternoon is what I've done since then, which has really been taking all that that I learned at Esri and focusing that on public safety, particularly fire and EMS, which is what my background is. So is anyone practicing in public safety? You know, any paramedics, firefighters, anybody? Okay. So you're GIS people, I'll assume then. All right, so what I thought I'd do is just start out very simply, and let me describe what a process is like for someone responding to a call. Well, we get a call from a scene, somewhere that we need to respond to. A unit comes from some base, some station, from some location to respond to that call. And in the case of EMS, we end up transporting that patient, in most cases, to the closest, most appropriate facility. Of those two phases, one of those we can't do much about. We can't change the scene that we're going to. That's the address we've been called to. The hospital is typically the closest, most appropriate facility. Not a whole lot we can do there, maybe route well to get there. But it's that first side, we're moving from a base that we can affect. What our starting point is to begin that call can be changed. So if we can change that position to somewhere closer to the call before the call comes in, we can actually shorten that phase of the call, how long it takes us to actually arrive on scene. And that's not just about faster response times, it's about safety. Because of those two phases, the time that we tend to run red lights and sirens most often is going to be in that response phase. And that's a very dangerous time to be in an ambulance. And so anytime we can cut that distance and time down, we're doing a favor both to the patient, the crews, as well as the public in general. So how do we do that, though? How do you change the starting point? Well, we do that through GIS by looking at what is the probability of a call being generated from any particular point within our jurisdiction in the next 60 minutes. And then regenerate this surface every 5 minutes. So every 5 minutes, we're looking ahead an hour as to where calls are likely to be coming from. That sounds a little bit like magic. People call these emergencies. You can't plan emergencies. Well, there's a very repeatable pattern to these emergencies. And through an application that we call the Demand Monitor, we can actually query this past history and build from that this surface that tells us where calls are likely to be coming from. And what I'm doing here is comparing 3 different queries of historic data, looking at how do we build a better query so that we can more accurately reflect what we see on the ground. And typically, once we manipulate these queries a little bit, I can go from about 75% accuracy to over 90% accurate to forecast where that next call is going to be coming from, or the next call landing in one of those colored areas. So if we know where we need to be 90% of the time, 9 times out of 10, we can put a resource there closer so that we're able to respond to that call. Then we use another application from our marvelous suite called the Deployment Planner. And what Deployment Planner does is rather than just looking ahead right now to the next hour, it looks ahead for the next season. So we're getting into the summer season now. So we can look through the summer and say, what is it going to look like for this summer? So that every hour of every day throughout that entire summer, we calculate what would the demand look like, and then what would be the best position if we only had 1 resource, if we only had 2, if we only had 3, if we only had 4, all the way up to whatever a full fleet would be. So we can pre-calculate all these positions so that we can then respond very quickly to say, all right, when we're dropped down an ambulance because one's gone on to a call, now these are the points that we need to cover. And what that also allows me to do then is to build a list of which posts or what locations should be planned in order so that post 19 is my most critical to fill right now, then post 13, then 10, all the way down to my last post at level 9 where I have 9 available ambulances. It tells me where I need to be for this hour on this day. And If they're green, it tells me they're covered. If they're red, it's not covered. So we can even make recommendations that say, move this particular unit to this location, move this one over here, and we can get everybody situated where they need to be to give that best sort of response that we could possibly have. That's improving the deployment side. On the dispatch side, we have a list of calls that come in. We have a direct connection to the CAD so that we can be bringing in calls as they're entered into the CAD and look automatically at what are the default 3 closest vehicles to each call. We can build different types of response packages if I want certain types of calls, if we have ALS and BLS, advanced life support, basic life support. For fire apparatus, maybe we want 2 engines, a ladder, and a battalion chief. We can build whatever the criteria are that we need to have responding to this call, and then look at the routing that we have, and we can actually also use TomTom data, which I know it takes away your ability to edit the street work, but it gives us the advantage of having real-time traffic. So now we know how weather is affecting traffic today, how another accident along the way is going to be affecting traffic, and we can have all the adjoining jurisdictions. So if we were to transport a patient out of the county to another hospital, we can still see where that unit is, where it can reach as it's coming back into the county, back into its own jurisdiction. And then we can bring that all together into a single map. So this interface that you're looking at now is what we call the deployment monitor piece. So this is what the dispatchers would look at in the dispatch center. So they have a map that shows them that hotspot map that updates every 5 minutes automatically. So the most likely calls, gradating out to the less likely areas where calls could be generated. We can also see where all of our units are, highlighted on the map. And then around each unit, it shows the drive time also in real time. So as that vehicle moves, we have a new AVL position for that vehicle, it'll calculate a new drive time. So even as it's driving down the highway to a call, it is constantly showing me where it can be if it's an available status. If it's not an available status, it can't handle anything else, and so I want that to disappear. So what I have then is that ability to see where might I be needed, where do I have resources, and what ability do I have to respond to calls along the way. So that works really well for ambulances because they're used to a very dynamic sort of response, what we call posting a lot of times. Because an ambulance, unlike a fire apparatus, is a fairly scarce resource. When you look at all of the public safety vehicles that you have within a county, there's typically a lot more fire engines, fire trucks, all those apparatus compared to the number of ambulances, even though the call volume for EMS, medical calls, is much higher. So it's a higher utilization vehicle, but they tend not to have specialization. They're scarce, so they tend to be more demand driven. So we can actually move these units around from location to location much easier than what we'd be able to do with fire apparatus. On the fire side, we tend to take a very different perspective. They have what we call first due areas, and that's a term that I really despise because it really does away with all the concepts that we think about in GIS. It's pre-calculating where can we reach, and it totally ignores the fact that if we have traffic in an area, a vehicle could sit still and its ability to serve can shift around it as traffic patterns shift. So it's not a static area that we can serve from any given point. And so we need to be able to model that. But it's not an either-or proposition. There's actually an entire spectrum between these ideas of a very dynamically posted vehicle using street corners and the very static idea of a brick and mortar station with a first due area that's predefined around it. So there's a whole lot of other abilities in there to be dynamic or to be more intelligent in the way that we move vehicles. And that's just a configuration change within the software. So I showed you the deployment monitor for working with EMS, but we have the ability to change settings in here to make it work for fire. So it's more of just an informed move up, a little bit slower movement. And here we can, again, consider how much overlap do we want to consider. The way we did in Deployment Planner for EMS, we can do the same thing with fire apparatus. The other thing we can look at is how much do we want to focus on demand, or that likelihood of calls coming in, or for fire risk, versus how much do we want to cover all the geography. And this is where some really neat GIS comes in for me, is this idea of what does dynamic risk look like for fire apparatus? Well, there's a lot of static factors that fire tends to look at routinely when they determine new planning areas and how they're going to staff certain stations. And that's going to be things like the density of buildings, the size of buildings, the overall fuel load. If buildings were to begin burning, where's the larger amount of load that's going to take more apparatus, more water to help put out? That doesn't tend to change much. Buildings don't move easily. Some areas that are growing very quickly, you may get a lot of buildings shortly, in a short amount of time, but they don't move very easy, so it's static information. There's some other static information we can look at, like vulnerability. I heard Hope Morgan talk about this yesterday morning. We need to be a little bit careful talking about demographics, but the thing about social vulnerability is these are the people who tend to call 911 more often, and these are the people who tend to feel more effects of those calls, whether they're medical, fire, or other types of emergency calls. These are going to be the areas that are going to be impacted a lot more. Again, they can be mapped out and known. Another static layer might be flood zones. A flood zone is typically a high-risk area, right? Well, yeah, as long as it's raining. But if it's not raining, it's not a high-risk area. We can still map them out, but then instead of looking at the flood zone itself as being a high-risk area, we can look at the stream gauges. And these are reported typically at least once a day. And then we can look at each of those stream gauges and see where are they compared to normal. Are they higher, lower, trending upward, trending downward? And that means that downstream, that defined area is either increasing or decreasing in risk as far as calls or the effect of calls that may come in that area. Plus, we have our traditional ability to look at demand. So where have calls come from on a Thursday afternoon at 1:30 in our area, so that we can look at that probability surface. That does change very often. In our case, typically about every 5 minutes. And then there's another piece of interesting information. I don't know how many of you may have looked at this before, but this is the idea of population movement. So population is typically something that we measure as being static, usually by a block group area. But this company, AirSage, can provide information about anonymized cell phones. So we walk around with these GPS devices that are pinging towers to let us know where these units are. So this is looking at the density of where people are, or at least where cell phones are, as an approximate measure of people, at, this is 4 o'clock in the morning. At 1400 or 2 o'clock in the afternoon, we see a little bit different pattern. As we move into the evening, we see a little bit different pattern. And they can provide this on an hour-by-hour basis, so we can actually see how population moves and shifts around our area. And then be able to take all of that information and collapse that into a single risk surface to become one of the factors from which we can balance geography and this risk in this balance of how do we place units or determine where to put units to then weight in this whole model. So GIS underlies all of this to ultimately display us a map that can be very hard to look at. So this happens to be in Mecklenburg County, but what we see here is a map with all the units on it and all their service areas and a lot of information, more than what anyone can really process in their heads. But the neat thing is we have this little dashboard at the bottom that can look at our fire apparatus and say that overall our ladders are still very good as far as the total number we have, and they're distributed fairly well. There's only one area that's a little bit low. Our engines, we still have a lot of engines, but they're really not distributed very well. And so we can actually look at and make recommendations to move very specific apparatus. Move engine 27 to fire station 6. Move engine 6 to fire station 4. If we follow all these things, we can balance then all of these competing interests, the risk, the geography, and all of that to make sure that we are pre-positioning that resource where it can reduce the distance and time it takes to get to that particular unit. And this is just a diagram that we can bring up for the users. I thought it would be interesting for GIS folks because it actually looks at every cell, the value, and if we move a unit, how does that change? And is it actually improving coverage or decreasing coverage by moving a unit from one place to another? So we build all these things dynamically in the background so that we can look at what are all the possible movements to then pick from that entire list what is the best choices to be made. And then underlying all of this, of course, is good data. So we need good addresses, we need good street networks. So if you're maintaining this, we also have tools that we had to build out of necessity to make sure that we had good data to be able to support these wonderful applications that we had. So I got us back on time, right at the 5-minute mark. So I know that was real quick, and there was a lot packed in all of that, but are there any questions I can answer? Back up through some of the slides and go a little bit slower through them. Well, if you think about questions, I'm right one of the center kind of booths next to the food area. So when you're getting your food, you can stop and ask me what you might be thinking about. Thank you for your time.